Welcome to today's video on limits and continuity. This is a fundamental topic in calculus, and it's particularly important for students preparing for Class 11, 12 mathematics exams like CUET, JEE, and CBSE. Let's start by understanding what a limit is. A limit describes the value that a function approaches as the input approaches some value. Mathematically, we write this as the limit of f of x as x approaches equals L. Think of it as answering the question. What value does the function get closer and closer to as x gets closer and closer to a specific value? Let's visualize the concept of limits with a simple function. Consider the function f of x equals x squared. What happens when x approaches 2? As x approaches 2 from the left, f of x approaches 4. Similarly, as x approaches 2 from the right, f of x also approaches 4. Since the function approaches the same value, 4, from both sides, we say the limit of x squared as x approaches 2 equals 4. Now, let's learn about one-sided limits. When we consider the behavior of a function as x approaches a value from only one side, we have a one-sided limit. The left-hand limit is written as limit of f of x as x approaches from the left. The right-hand limit is written as limit of f of x as x approaches from the right. Let's visualize this with an example of a piecewise function. Let's analyze the one-sided limits for this piecewise function at x equals 2, as x approaches 2 from the left. F of x approaches 3, because in the left piece, f of x equals x plus 1, so f of 2 would be 3. As x approaches 2 from the right, f of x equals 4, as defined in the second piece. Since the left-hand limit is 3 and the right-hand limit is 4, we can see that the limit doesn't exist at x equals 2 because the left and right limits are different. Remember, for a regular two-sided limit to exist, both one-sided limits must exist and be equal. Now, let's talk about continuity. A function f is continuous at a point a if three conditions are satisfied. 1. F of a is defined, meaning the function has a value at x equals a. 2. The limit of f of x as x approaches exists. 3. The limit of f of x as x approaches equals f of a. We can write this mathematically as f is continuous at x equals a if and only if the limit of f of x as x approaches equals f of a. Let's look at examples of continuity and discontinuity. First, let's consider a continuous function, like f of x equals x squared. This function is continuous at every point because at any point, f of it is defined. The limit of f of x as x approaches exists. The limit equals f of a. Now, let's look at three common types of discontinuities. First, a removable discontinuity or a hole. This occurs when the limit exists, but either the function value is different or not defined at that point. Second, a jump discontinuity. This occurs when the left and right limits exist, but are different. Third, an infinite discontinuity. This occurs when the function blows up to infinity as x approaches a certain value, like in f of x equals 1 over x minus 2 at x equals 2. Now, let's look at how to calculate limits algebraically. There are several techniques for finding limits. First, direct substitution. If f is continuous we can just plug in the value. For example, the limit of x squared as x approaches 3 is just 3 squared, which equals 9. Second, factoring. This is useful for limits that give an indeterminate form like 0 over 0. For example, the limit of x squared minus 9 over x minus 3 as x approaches 3. We can factor the numerator x squared minus 9 equals x minus 3 times x plus 3. Then we get x minus 3 times x plus 3, all over x minus 3. The x minus 3 terms cancel out, leaving us with x plus 3. Now we can substitute x equals 3 to get 3 plus 3, which is 6. Third, rationalization. This is useful for limits involving square roots. For more complex limits, especially those involving indeterminate forms, we can use other techniques like L'Hopital's rule, which you'll learn in advanced calculus. Let's conclude with some key points and exam tips. Key points to remember. A limit describes the value a function approaches as the input approaches some value. For a limit to exist, both left and right limits must exist and be equal. A function is continuous at a point if it's defined there, its limit exists there, and the function value equals the limit. For your exams, especially CUET, JEE, and CBSE, be familiar with standard limits like sin of x over x as x approaches 0 equals 1. Practice both algebraic and graphical approaches to limits. Review common types of discontinuities and identify them in functions. Know how to use factoring, rationalization, and other algebraic techniques. Mastering limits and continuity is essential for calculus. These concepts form the foundation for derivatives, integrals, and many important applications in mathematics and physics. Thanks for watching. Good luck with your studies.